All right. So today we will start with the module 6 assignment. This is the practical part. So in this, I
Mhm.
have taken the one data set. This is the IRIS data set. So this IRIS data set is basically very, very popular for the classification. Like what type of the flower is this?
Mhm.
So if you look at this here, so this is the data dictionary and about the data set. So we have this is target. What type of flower you have? You have a three different type of the flowers. And these are the features like sepal length, sepal width, petal length, petal width. So
Sure.
based on this, we will predict whether this is setosa, whether this is versicolor or it's virginica. So what type of the
Okay.
flower is this? So what we call this process, John? If when we are talking about this portion, what we call in machine learning this portion? Any idea?
Um, when you're putting the data set in or when you're running
When
the,
we are discussing this, like what features, what is goal, what you want to
oh, these
predict.
are, oh, these are the, not the exclusion. These are
Yeah.
just the inputs, right?
Yes. Remember we did cycle.
Yeah. Okay. These are inputs. Yeah.
This is business understanding.
Right.
Okay. This is your first step. Okay. When I am like telling you or your stakeholder or you are as a data scientist, data analyst, when you
Mhm.
are discussing about the data set, this is called business understanding.
Business understanding.
Okay. So
Okay.
in this, you will understand what you are going, what you will do with the data set.
Mm.
Okay. How many
Okay.
features,
We got 7.
right? How many
Well,
records
let me see. I didn't see it. So
and what is
okay.
goal and
The goal. Yeah.
type of problem. Is it classification or regression?
It's classification.
Yes, right? So if this is correct, then only your analysis will be correct. Okay.
Okay.
So here we are importing the files, sorry, libraries. So this is your pandas, numpy, matplot, seaborn, plotly. Plotly I'm using today for 3D graph. And
Oh,
this is
okay.
this one.
Mhm.
And
Got it.
this is a sklearn dataset. I'm not downloading the dataset from Kaggle. I'm loading the dataset from sklearn datasets. If you remember, I think I
Yes.
discussed about it, right, in previous module.
Yes. You did.
So I'm using it. So I'm downloading the load iris dataset here. SNS.set style is equals to white grid means what whenever I'm drawing the graph using Seaborn, its
Hmm.
background will be white by default. Okay.
Okay.
You can also do that if you want for all graphs. And here we are loading the data set. So this is load iris.
Oh, okay. Right.
The data set is like this. See,
Hmm.
here we go. This is your target. These are your sepal length, petal width, or
Yeah.
your petal length, right?
Yeah.
And these are the name of the features. So now this data set is in the array or dictionary form. First, we will convert it into data frame. So here we are just checking. And now this is the code you will convert into the data frame. df is equals to pd dot data frame iris dot data. Why did you take the
Okay.
iris dot data? Any
That came
idea?
from the sklearn data sets.
Yes. And did you notice here your all values are stored in this?
Under data.
Yes. and this is dictionary, right? This is key value. And in pandas, when you want to fetch out the value from these, this is the like the variable in which you load the data, and this is the part of the that one. Column is equals to iris dot feature names. Feature name is
Okay.
another here. If we look at this,
Right on. Okay.
okay, so it will be here. Where it is gone? It should be here. Feature names. I'm not able to see, but it is here. Okay. And then here you go. This is here. Okay.
Feature name. Yes.
Yes.
Definitely with
So this is
the
in
elements.
form of dictionary. Do you have idea what is dictionary?
One more time.
Do you have an idea what is dictionary?
A dictionary. It's where you're defining your terms in the program, right?
No. Have you like done the dictionary in Python? It is
No.
like this. See, data. It is like this.
Oh, okay.
It is like this. Right now we have a like this, right? So we have a, let's say iris, comma, features,
Uh-huh.
like this, and this is features, okay? And now if you want to access it, if you want to access a specific value, what I will do, I will write dic underscore data, square bracket, data, like this.
And then data. Okay.
Hmm.
So now it knows. It encapsulates all that, all the everything, the sepal length, the pedal width, everything like that under data.
Yes, you are right.
Okay. Got it. Got
Okay.
it.
That's why we are doing here pd.dataframe iris.data, right?
Okay. So yeah. So okay.
Yes,
Got it.
because we load all the data inside the iris variable,
Uh-huh.
right?
Yes.
So this is
Mhm.
the reason. So this is extra, I will delete. And now, if you want to print it, let me print it alone. We can drop it here. If you want to see, it will be like this. See?
Mm.
Okay. So here we
Okay.
have a columns is equals to iris dot feature names and then iris dot data. Okay. So
Uh-huh.
this will
Okay.
come here and this will do this. So in pandas, if you want to rename the column, you need to use column parameter for that. Okay. And
Okay.
now we want to separate the target. So what you will do? You will separate the target here. So you will say here df dot species. You can give any name. If you want to name it target, you can keep the target column name. It's not mandatory, like you need to keep it for that thing. Okay. See,
Okay.
so you got
Mhm.
the target too.
Yes.
Okay. And now we are just mapping how it look like. Then it will be in this form, the complete one.
Okay.
Are you okay, John?
Yes, I'm okay.
Now we will start the EDA. Do you remember what does this method do? df dot
It's,
display.
what does that do?
Just try to remember in previous modules we discussed about the statistics of the each feature. If you want to see the statistics of each feature, statistics means if you want to see,
Oh, okay.
remember mean,
The mean and
mode, median, right?
the mode.
Standard
Yeah, right.
deviation. Then this is the method you use.
Okay.
Okay. And this is very common interview question too.
Thank you, sir. Mhm.
Here you can see mean, standard deviation,
Mhm.
minimum, and maximum. And these are
Mm,
interquartile range. Remember 25%, 50% when we did the box plot. Oh,
right.
you were not last time in the live session. I
I was
explained
not.
it. So I explained box plot there, interquartile range.
Okay.
You can watch the video, right?
I will watch that. Mhm.
And then here we are just checking this thing, but this is called EDA. EDA means exploratory data analysis. We are just exploring the data. Okay, how does it
Okay.
look like? And this is a correlation. What is a correlation? Remember, John, what is correlation? Are you
You
feeling
should-
sleepy?
No, I have ADD, and so when I'm going fast and thinking a lot, I yawn. Um, Correlation is when is when you one primary action meets up with a secondary cause, and we see how many times that cause and action go together. And the more they go together, the more correlated it is. That's what creates the p-value.
So you mean two features are correlated with each other,
Yes.
right? Yes,
Yeah.
this is called correlation. Now, if we look at this, we are just finding the drop species. Here, your sepal length is negatively correlated with the sepal width,
Yes.
minus
Yes.
11%, right?
Right.
87% correlated with the petal length. It's highly correlated, right? And then
Hmm.
petal length, this one. Okay. But here, our goal is not looking at the relationship between the independent feature. Otherwise, your model will be in trouble. Your
Okay.
model will become biased.
Yeah.
Okay. So we only want our independent feature to be highly correlated with target. Okay. How good they are to predict the type of flower. Okay. Now look
Okay.
at this. So here I'm using SNS heat map. Now look at
Yeah.
this. This is called
Hmm.
heat map. Did you draw this map in your any assignment?
I've seen this before. I haven't drawn one yet. Correlation
Okay.
heat map. Yeah.
So in this, if you look at this bar, this is called color bar.
Hmm.
Here you can see it is negatively correlated. Here is a 0. Above all these values are positive and
Right.
all these values are negative. So this is negatively correlated. Darker the color, this means negatively correlated with the target. So you can
Right.
see here petal width is negative 37%.
It has no effect, right? It doesn't tell you anything. Right.
Yes, this means if one is increasing, other is decreasing, right?
Hmm.
Opposite
Right.
relation. And if it is
Opposite.
87, both are increasing in the same direction,
It tells you a lot. Right.
right? So
Right.
diagonally, this is all one because every feature is
Mhm.
self-correlated, right?
And then conversely, the 0.87 and the 0.82 will be pedal length and
Yes.
and the pedal length. Mhm.
Okay. Do you know what type of, how many type of correlation is?
Would you ask me one more time?
How many type of correlation we have in your, in like a machine learning? Like we are talking about here correlation, right?
Well,
So
you would
how,
have three, right? You would have positive correlation, negative correlation, and no correlation, right?
very good, right? When
Hmm.
it sees 0, this means this is no correlation, right? Or either
Yes.
your graph is going just like this.
We can't predict anything, right?
Yeah, we
We have
can't
no
predict
idea.
anything, right? So
Hmm.
this. So here, this is the next visualization. See, we are looking
Hmm.
at the sepal length and sepal here, the total frequency. In this, did you notice we are only showing here one feature,
Yep.
right? It is a frequency. So when you are
Right.
showing the one feature on the x-axis, there is a no other feature. You are just looking at the frequency. So how
Yep.
many records do you have whose sepal length is 6.2 or 6.3? This has around maybe 28 or 30, right? So you
said,
have a more records, the highest records with the length of 5.5, right? And with 6.8 or maybe 7.1 has the minimum record, right? With this length. So when you have a one feature, this is called univariate visualization. Technically, in interview, sometimes they ask you the question, what is the difference between univariate, multivariate, or bivariate?
Univariant,
Univariate, this means single
multivariant.
feature, right? You are showing the single feature frequency,
Yes.
right? Bivariate means two feature.
Yep.
Multivariate means more than one. Okay. So
Yes.
multivariate, bivariate, sometimes it's the same if you have a two feature, but sometimes you have a three features, then that is multivariate. But
That's
above that
multivariate.
we can't display, right? Only
Right. Well, we
3D.
don't talk about that.
Yes, only 3D is
Right.
possible. Look at this. This is what we were I was talking about it. This is
Yes.
interquartile range too when we look at it. Do you know the name of this graph?
No, I don't.
Mm, this is called box plot.
A box graph. Okay, great.
No, box plot.
Box plot.
Okay.
Okay, got
And you can, and many questions come on this graph specifically. This
it.
graph is popular to show outliers. Very important.
It also, yeah, it shows there's no overlap of the species. That's good.
Overlapping as well, and your this whisker should be in a good shape. Box. And if you have any here the balls, this one points, this is all outlier.
Oh,
This is outlier.
gotcha.
Okay. And this is
Mhm.
like a most popular graph which every data scientist draw or data
Okay.
analyst to check outliers.
Okay. Yeah.
Now if you look at this Setosa, first I will
So the
tell you,
boxes, I'm sorry, teacher, go ahead.
yeah, this is maximum length. I mean
Okay.
maximum value, right?
Right.
This is called minimum value. It can be negative, it is positive. Okay?
Right.
And this is called median.
That's the medium.
Yes.
Okay.
And this box we call it whisker 2, right? And this portion, this is Q1, this is Q3. Quartile 1, quartile 2. Okay? And this is this portion, this is called interquartile range. Q3 minus this is called Q3 minus Q1. We find it. Okay. And this will become
Q3
your,
minus,
yes, Q2.
right. Okay.
Or interquartile range, we call it this one. We have a Q1, Q3, IQR.
Okay, so Q2, whereas does Q2 is the derivation of Q3 minus Q1?
Yes, you can say, but basically we use this interquartile range. We call it
Interquarter range. IQR, ICR?
yes, quartile range.
Okay.
Okay. So I have explained it very well in the previous video too. If you watch it, I will share a
Oh,
link
okay.
with you as well for the
Okay.
article too. Okay.
Awesome.
And here, if you look at this, so first of all, we will look at the Setosa. So why we draw it? First, to check the outliers. Second, distribution. If you look at the Setosa target, we are just looking at the Setosa petal length, right? So petal length distribution by species. So your petal length for Setosa type flower, you have a very low records. This means your type of Setosa flower has only the petal length between 0 to 2 maximum,
Ah, right.
not more than that. Okay, not more than that. Now, if you look at this versicolor, you have some outliers whose minimum length is 3, but basically you have a length between 4 to 4.67, whatever you can say. Okay,
Right.
and
Okay.
maximum it can be go 5.1. Okay, but your most data records lie between this range,
4 and 4.6. Yeah. Mhm.
right? And
Right.
Virginica has a this. So what does this graph is showing right now? It is telling you the distribution of petal length based on the type of species or type of flower. Okay, whatever it.
Right. Sure.
This is very popular. You know, whenever you are looking at the graph, just Google how to interpret the graph. If you want to be a very good or like a very strong in your skills and you want to be the best data analyst, if you don't know how to interpret the graph, there is no use. Here we have scatter plot. See, scatter plot is very popular,
Awesome.
right?
Hmm.
When you want
Right.
to show basically the relationship, right? We use at that time
Hmm.
when two features. So here we are showing the relationship between sepal length and petal length. Would you like to interpret this graph? Do you
Sure.
want to try?
Sure.
Mhm.
We've got when the sepal length clusters around 5, we've got petal length that is about 1.5. And then when we have sepal length that clusters between 5.5 and 6,
Mhm.
our petal length is going to be about 4.2.
Okay.
Sorry about that. And then when our the Virginica will have
Mhm.
it's I don't know, it's so spread out because we have some outliers there. Um, I would say it's around 6.75. When it's about
Yeah.
6.75 sepal length, we're going to have 5.5 centimeter petal length.
Mm-hmm.
So
Very good.
it will tend to be the largest. Yes, the Virginica will tend to be the largest. Versicolor will tend to be second largest, and the Setosa will tend to be the smallest.
Mm-hmm. Very good. Yeah. And in either way, I will make more addition. This is correct, what you have explained. Much appreciated. So here it is showing the three different type of species. If their sepal length is increasing, petal length is also increasing, right? If I
Mm-hmm.
ask you, can you tell me what type of the species petal length and sepal length is affecting lot? Like if you look at this, the blue color is
Yes,
what Setosa, right? So if the Setosa's length is 4.5, 5.0, 5.5,
it
right?
has no correlation.
Yeah, it is
The
not,
sepal length
yeah,
does not
no,
correlate with the petal length at all.
right.
Right.
And your versicolor has some relation, right? If it
Yeah,
is,
it has some relation, but it's because the petal length is only as low as 3 and it never goes above 5.1.
yes,
It is a very tight uh, parameters for the length of petals. It
yeah.
does it correlates, but it's a mild correlation because
Mm-hmm.
it's so structured with the petal length. But the Virginica has wildly varying petal length.
Mm-hmm.
It does correlate. It correlates weakly with the sepal length.
Yes.
So because we do have a lot of outliers, like right about 6.5, there's some that are just huge petals. So it tends to go up. They tend to go up together. They tend to be correlated, but every now and then you'll have um, strange breeding. Probably is what's going on there. You might have it's probably planted in different areas and getting different nutrients.
Yes, very good, very good. Very good explanation, right? So this
Mm.
is how you need to interpret and look at into it, right? So you need to
Right.
think like how it is useful. If I'm your stakeholder, what is the useful result I can see from this, right?
Hmm.
So this is our
Right.
goal. So here we are showing this one scatter plot. You can now imagine if you
Right.
have a two numerical variable, you can draw the scatter plot if you want to show the relationship, right? And this
Hmm.
portion is called legend, right? And
The legend. Right. Hmm.
yeah, these are your titles.
Hmm.
Now this is the one your advanced one graph,
Oh, sweet.
right? So this is called 3D. Okay.
Right. Uh-huh.
Now if it is not clear, then the biggest advantage is you can download it, you can zoom in, zoom out, you can just make it like this if you want to see it.
Oh, uh-huh. Yeah.
Okay, so it's a very interactive. Okay, and I have
Yeah.
drawn it using Plotly. Okay, this is from
Okay.
the Plotly library which we have imported at the top. This is
Hmm.
Scatter 3D, and then although I don't like 3D graphs, it's a tough to explain. Look at this.
Yeah.
Sepal length, sepal width, petal length.
Oh, it's so much better. It's so much better. Yeah, they're clustered really tightly
Yeah,
with
look at this.
sepal width. Yeah. Hmm.
If you want to see like this, you can.
Hmm.
Okay. So here the sepal length we can see when I'm hovering on that, it is showing
Hmm.
me. If your sepal length is 5.4, your sepal width petal length is this,
Hmm.
right? So it's a very clear.
Yes.
Otherwise, in other graphs, you need to add the tools, toolbar, right? Tooltip. You
Ah,
can do
okay.
that, right? So here you can visualize it 3D because I'm using three features,
Hmm.
right? So this
Right.
is very, very good, although in real time, but in real time, when we are going to present our reports, we don't use it actually.
Oh,
Very,
really?
yes, very rare we use it because you can see a non-technical person, right? If the person does not have any much knowledge, they won't be able to understand it too much.
Oh my
Basically,
gosh.
most of the time you are going to use bar plot, pie chart. Pie chart is rare. If you want to show some percentage, you will use bar graph. You will use histogram.
We use the 3D among ourselves, and then we'll show the 2D to the client.
Yes, you can show 3D if you are good in explanation. Okay, if you can
Hmm.
explain it. You can use here line chart, scatter plot. These are the four popular graphs actually basically we use. Okay, because
Scatter
we
plot.
can
Yeah, yeah.
make it very interactive. Right now you are looking at the graphs. These are not too much interactive, but I will share with you the more libraries. You are
Okay.
going to love that. If you want to practice, if you have a time, you can. Okay.
Okay.
So these are the some theoretical part, how you can make the reports, how you should be a good storyteller. You can go
Uh-huh.
through this notebook, right? It is already on the drive actually.
Okay.
Okay. Now I will tell you the sites. Okay. I will share with you this one. Box plot interpretation. So it will be helpful for you. Mm, I think Geeks for Geeks is good. Here you go. Okay. So look at this. This is Q2,
Oh, yeah. Gotcha.
Q1, Q3, 25. This is 25, 25, 25. They are showing like this minimum, maximum, right?
Mhm.
Four portion
Yes.
divided total 100% and
Hmm.
IQR. And the most important is this, John. When you have a outliers, how you are going to handle? You will calculate lower limit and upper limit. How? Let's suppose you have a one feature sale price or
Hmm.
maybe salary, you can consider any, right? So
Hmm.
200K, 250K, 300K, this is normal range, right? But
Right.
after that, you have some outliers, 1000K, 1500K, maybe 900K, 800.
Well, instead of using, well, you could do a variation on the box, and you could do a gradient,
Mm-hmm.
where it changes from like dark in the middle and then becomes lighter towards the edges. So you can communicate to them that this is what you should expect in the middle. Although you might get lucky, it might get high, you might be unlucky and it comes in low. Right.
Right. And then here, what you will do, you will find out the lower limit.
Hmm.
Okay. Q1 is your minimum value. So what you will do, you need to apply the formula here. You have a pandas, you will say DF sale price minimum value, then maximum
Right.
value. Okay, you will got two values, and
Right.
then you will have the Q1, Q3. You will put that, and you need to calculate IQR Q3 minus Q1, and you
Hmm.
will calculate this value. Let's say you got a minimum range, maybe 200, and a maximum
Okay.
range you got maybe 1200.
Hmm.
Okay, so
Right.
now you can select the all values of from this feature box between this range. This is
Right.
how we handle the outliers actually. Okay, so this is very, very important. There are more ways to handle the outlier, but this is the most common way. And I will
Hmm.
share this link with you. You just bookmark it.
Okay.
And I will show you one more library. This is your Plotly. This one. This is very good library. Examples. Hmm. See, these all are apps actually, but we can go to here resources, documents, and this is how you can start this one. Chart prompting. This is all documentation, but there must be one your graph too. This is not. I think dash dots. Mhm. Yes, this is the one. See, these
Oh, yes.
right? So
Those are awesome. Yes, 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 yes,
yes,
yes. Oh, I love
right?
these. Hmm.
And you can easily add it. It's very easy to add. Okay.
Yeah.
So you can see you so this way what you can do, you can also build a very beautiful graphs using Python too. Okay. If you
Mm.
don't want to
Yes.
use Tableau, you can just copy and paste this code as it is, import libraries, whatever they are asking you.
Really?
Yes. And
That's so
you,
cheating. That's awesome.
yeah, no, for learning.
Oh, for learning. Yeah, for learning.
Yeah,
Yeah, right.
not
Yeah.
for real
Yeah.
time,
Oh,
for
yeah.
learning.
Yeah,
Okay.
right. Yeah, just for learning. Yeah. Oh,
Yes, for learning only, not for you. You can't use it direct. You can, but for real time, definitely you need to embed your own values, right?
sure. Hmm.
So this is, I like it. You can either use a JavaScript for this one. See, this is also box plot. See, it's so
If I knew
beautiful.
if I knew what JavaScript was, maybe. But yeah, I'm a teacher. I don't know anything really.
Okay, if you do JavaScript, basically we use to make it more interactive.
Yes, yes. I remember when everybody was doing, oh,
Yeah,
it's Java. It's awesome. Yeah, it's cool.
right? And if you want to use Python, this is Python. I will share this link with
Mm.
you. It will be easy for you. There is a one more library. I just forgot the name. That is very, very beautiful.
Mm.
And you will find plenty of graphs inside this. See, but you need to draw these graph when it makes some sense to the user. Most probably, John, in real time, you are going to use these two maps. Map is very, very popular graph. Like,
Oh, that's where I am. Look, teacher, that's where I am. If you go back. So on your right hand side, you have the United States. You have the orange. Yes, where your cursor is right now. That's almost exactly where I am right now.
oh,
The orange at the top there.
yeah,
Very cool. So you're using, oh, neat. Oh, wow. Okay.
okay.
So when you drag over, it pulls up this is like the 3D model that pulled up the coordinates when you were doing that. Okay.
Yes. So here, this is, here we should have America. Here we go. This is showing here. You can make it like this too. So these graphs which you are going to use in real time most of the time.
Oh, okay.
And map is not is of a one type. It's a multiple type. So it depend upon
Bubble
your
map.
stakeholder, whatever they like. They might like this green one,
Hmm.
right? They might like that one. It depends, right? See this one. It is showing the
Hmm.
unemployment rate. Okay. So if you want to be expert in graphs, you can try this one. Dash, if you look at this is bioinformatics. This is more AI and ML graphs. This is
Hmm.
more your regression. See, this is
Right.
regression graph. You can learn, John, from this how to add a tooltip. This is tooltip. Did you notice when I'm hovering on that, it is showing me all values? See?
Yeah, it's showing you all kinds of things.
Yes. So learn these things. Okay. This is important. And you can
Mm.
just copy and paste this one. I think they are using total build data set. You will find the data set here too, somewhere. They will have. Okay. You can download and just try these graphs. Okay.
Okay.
These are important. If you want to be data analyst, get expert in these things. I forgot the name of one library that is awesome
Hmm.
for graphs, but in real time, work on map, work on line chart, work on bar
Yes.
chart, histogram, and your
Yes.
box plot. That is sufficient, more than sufficient, and you should know the interpretation of these as well.
Oh no, that's great. Yeah, because I can read I can read the numbers and understand it, and on the charts especially. But the real time, the bubbles and stuff makes it where you don't have to explain it to people again and again and
Yes.
again. Yeah.
Yes. Any other question in your mind?
No, ma'am. No other questions. Thank you so much for taking your time and showing me that. I really appreciate it. I
No
really
problem.
enjoyed it. I don't know if you can tell, I really, really enjoyed it.
Okay, great. Okay, John, thanks for coming as well. And I will see
Okay.
you in the live session next week. Okay, take care. Have a
Okay.
good
See you next week.
weekend. Yeah, bye.
Have a good week. Okay.
You too.
Bye bye.
Bye bye.